Hello guys, welcome back to Math Zone African Motives, still on mathematics and 4, that is working on the binomial theorem, which is an expansion that is very, very important in our syllabus that we can work with, also on the derivatives when you are working with the first principles. But as for this part, we just need to focus on the binomial expansion separately, not on the application of derivatives, but on it separately. So I'm going to introduce you to this part so that you can be able to attempt questions like these ones where you're being asked to expand to 4 terms only by using the binomial theorem if you're given this part. And also check that the link of the PDF on the description of the video so that you can also have your own copy of the PDF that I'm having here. All right, so like I said, I'm going to explain from the basics so that you understand where is this actually coming from or where is it being taken from. The binomial expansion is used on expansion of a condition. Maybe you've got x plus h to the exponent of n, where it can be a negative exponent or a positive exponent, a fractional exponent, a fraction. Actually, we can have it as a fraction. We can have it as a whole number, which is a negative, or as a positive. So whatever format that you're given, for example, we are referring to something like x plus 2 to the exponent of minus 2, x plus 3 to the exponent of 7, x plus 4 to the exponent of negative 3 over 4. It can be a fraction, it can be a whole number, it can be a positive, it can be a negative. So this is where we can apply our binomial expansion. And normally in our syllabus, up to 4 terms, we can apply this up to 4 terms, which states that we are going to have this expanded as x to the exponent of n. So what is going to happen? X starts with the exponent of n, whilst h is starting at the exponent of 0. All right, so plus, so what you're going to do, you're going to apply like a derivative concept, all right? The derivative concept that you drop the exponent, you subtract 1. Drop the exponent, on x, you're focusing on x, that derivative concept. So this one is going to be any x to the exponent, we subtract 1 on the exponent, so this will be minus 1. All right, so for any, you are dropping the exponent, you're subtracting 1, whilst h is increasing. Remember, h started at 0, so this will be h to the exponent of 1, everything over 1 factorial. So 1 factorial, I'm going to show you this from your calculator. So that is going to be the sequence until it does not end, like you're going to have this and so on and so on. All right, so this is the same concept here. Like I said, for x, you drop the exponent. Where there is x here, you drop the exponent. So that is going to be already, there was n. So it is going to be times, we drop the exponent, which is n minus 1, this one. Then you subtract 1. So it's n minus 1 minus 1. You are subtracting 1. So minus 1, that's minus 2. So it is going to be x to the exponent of n minus 2. Whilst h, like I said, h will be increasing in terms of its exponent. So it's now at 2. Everything over the factorial on h, which is 2 factorial. All right, so that is what you're going to have. Plus, on x, you drop the exponent, you subtract 1. So this is at n times n minus 1, which was there. We drop this exponent, which is n minus 2. So if we drop our exponent, we are going to have this as n minus 2. X to the exponent, remember I said you subtract 1. So it's n minus 2 minus 1, minus 2 minus 1, which is minus 3. H is increasing, so it's h to the exponent of our h. So this is n minus 3, sorry, this is n minus 3. Minus 2 minus 1 is minus 3, but there is n there. H is increasing, now it's at exponent of 3 over that factorial of 3 factorial. So this is going to be and so on and so on and so on up to, I don't know. So depending with the terms that you're given, this is the concept that you're going to have or that you need to understand. Okay, let me explain this with this example so that we can just see what is happening here. Let us just have something of this nature, x plus 4. So let us have this as x plus 4. All right, x plus 4 like this to the exponent of 4. So remember, we can't use exponent of 3. Yes, we can use that as an example, but exponent of 3, we can expand that even without the binomial expansion. But these higher exponents are the ones that you need to work on. All right, so like I said, guys, let us be together here. We said the first thing, x is going to be raised to the exponent of n, which is the exponent here, which is your power, the exponent. So that's x to the exponent of 4 in this case. While our h in this case is represented by 4. So 4 is representing h. So this is going to be 4 to the exponent of 0, of which 4, guys, just take here h to the exponent of 0 in this case. H to the is 1. So it's just like 4 to the exponent is, but just for the simplification part, so that we understand, it is supposed to be like this: 4 to the exponent of a 0. All right, we move on to the next term. We say, I take note about this, guys. You do for x, you find the same way that you do on your derivative. You drop the exponent. If it is n like this, you drop this exponent, so that is going to be n x to the exponent of n minus 1. So that is the concept. So here, our exponent is 4. So we drop that exponent to multiply this number. So we're going to have plus 4 times 1. This is the same as there's a 1 here. So it's 4 times 1, which is 4. The moment you drop the exponent, you subtract 1. So it's n minus 1, which is going to be a 3. So that's 4 minus 1, which is 3. Whilst 4 is increasing its powers, as you can see now, it's h to the exponent of 1. So it is going to be 4 to the exponent of a 1. Everything over 1 factorial, like this. So that is how we are going to have it. Plus the same thing, we drop the x long for x, we drop the exponent, which is 3. So it's 3 times 4. Take note, 3 times 4. So we're going to have plus 3 times 4, which is 12x to the exponent. You subtract 1 on x. So it's 3 minus 1, which is 2. Whilst the h, which is our 4, is increasing its power. So it's going to be 4, everything to the exponent of 2. It's increasing over the exponent here, or the 2 here on h. This one, or on h, is the one that you use on your factorial. So it's over 2 factorial plus, we do the same thing. We multiply again. So this one, why am I having a plus and a plus here already? We've got 1 plus here. So this is just 1 plus here. So plus, again, we do the same thing for x. We drop the exponent, subtract 1. So you multiply 2 times this, 2 times 12, which is 24. We subtract 1 on our exponent. So if we subtract 1 here, this is going to give us a 1. So that's x to the exponent of 1. Then 4 is increasing its powers. It's at 2 now. So it is going to be times 4 to the exponent of 3. All right, over the exponent of 3. This is 3 factorial. So that is what you're going to have. Plus, now this is a 1. So you drop the exponent again, 1 times 24. So this will be 24x to the exponent of 1 minus 1. Remember, we subtract 1 on x. So 1 minus 1, that's a 0. X, which, or h here, which is 4, is increasing. So that's 4 to the exponent of 4. So the now is to the exponent of 4. Everything over 4 factorial. So take note, that is what we have. So as you can see here, we are going to see that at the end, here, if we drop the exponent of x, this is now a 0. So 0 times 24, that will be a 0. So there's nothing that you're now having. So this one, it ends at this point, because the moment you drop this exponent, it is going to be 0. And 0 times any number, that's a 0. All right, so this is what you have, guys. This is how you apply your binomial expansion or theorem in this case. It's just like for x, this part of x, you work it as a derivative. So you multiply here, you subtract 1. So that's 12 to x to the exponent of 2. So that's what you're going to have throughout. All right, so how do you simplify this part here? You can just use your calculator at once. All right, so we are saying x plus 4 being raised to the exponent of 4 is going to be equal to, remember, any number to the power of 0, that's a 1. So this one gives us a 1. 1 times x to the exponent of 4, that's x to the exponent of 4. Then here we can simply use our calculator direct. All right, so let me show you on the calculator how we can have this direct. on our calculator, in this case, we can actually have this. All right, so let me show the other part of the screen here. All right, so that's this one. So this is 4. So you multiply these numbers here on your calculator. This is what you want on your calculator. You want this part of 4 and this part and this part. The x is going to remain as it is, this one. So, okay, let me show you what I'm trying to say. So we are going to have this as, put a fraction. So that's 4 times 4 to the exponent of 1. So this is 4 to the exponent, which is just 1 here. 4 to the exponent, which is just 4, all right? All right, everything over 1 factorial. So this is 1. The factorial is on this part, x factorial here. So it's a shift to this one. It gives you a factorial like this. So this is going to give us a 16. So that's 16 x to the exponent of 3, all right? So we are going to have plus 16 here, all right? So let us have it here. So we said we are going to have plus 16x to the exponent of 3. All right, the same thing here. We are going to have the same thing on 12. So we are going to simplify. Let's see what you're going to have. So like I said, we simplify the numbers only. So we are going to have 12 times 4 to the exponent of 2. So this is 4 to the exponent of 2 over 2 factorial. So this is 2 factorial, which is like this. So we are going to have 96 in this case. So this is going to be 96 at the end. So take note of the numbers that you'll be given at the end. All right. So that will be 96. All right. So it's plus 96 x squared. So this is 96 x squared. All right. So this is x squared. All right. The same thing on 24. And these numbers, so we're going to have a fraction again, 24. So that's 24 times 4 to the exponent of 3. So that's times 4 to the exponent of 3, everything over 3 factorial like this, okay? So this is going to give us 256. But here it's x to the exponent of 1. So it's going to be plus 256x, all right? This part here, we can simplify. Remember, I said x to the exponent of 0 is a 1. So we are going to have this. I want you to see what is going to happen here. So it's going to be, okay, let's have a fraction. First here, let's have a fraction. So that will be 24. So we are going to have 24 times 4 to the exponent of 4. So that's 4 to the exponent of 4. Everything over 4 factorial. So this is going to be 4 factorial like this, which is a 256. So we are going to have 256 at the end here, which is plus 256. So what I wanted you to see is that it's simply the same. If you start with the x to the exponent of 4, you are going to end with the 4 to the exponent, which means this number represents x to the exponent of 4, which is 4 to the exponent of 4. So this represents 4 to the exponent of 4 like this, which is 256. So this is another thing that you need to cross-check, that if you start with the exponent of 4, you are going to end with exponent of 4, provided that it's a positive. For a negative, that one, it does not end. For a fraction also, your expression does not end. All right, so this is how you apply the binomial expansion, guys. The binomial expansion is simply a direct thing on the x. Perform it the same way you do it on the derivative. Drop the exponent, subtract 1 throughout until the end. But if it does not end, then they'll ask you to leave your answer up to 4 terms, just like this question that you are given here. All right, November 2015, question number 4. Expand to 4 terms only by using the binomial theorem if 2 minus j to the exponent of 7. Okay, we are given 2 minus j to the exponent of 7. Whenever we see a j, this is engineering, guys. Whenever we see a j like this, we know that we are back to complex numbers where j represents the square root of -1. And I also said from our complex numbers that j squared is equal to -1. So it means once we see the j, the same application or the same concept that our j uses is the one that you're going to apply in this case. All right, so the first thing that we're going to do is to rewrite in a manner that we saw previously. We saw this is supposed to be x plus. If we check on our simplification here, this is x plus h, So meaning to say, we are going to put a plus in the moment that we put a plus, we are just trying to separate so that we see our x and we see our h. So this is the same as 2 plus minus a j like this, so that we see the plus, the minus j in this case. On this case, this is a minus j. Remember, plus and minus is the same. That's a minus. We haven't changed anything. All we just need is to separate to see the part that is representing our x and the part that is representing our h. All right, so this whole part here is being raised to the exponent of 7. So like I said, this part is the one that represents our x, and this represents our h. All right, we saw that from our formula that x is being taken from the first exponent. So meaning to say, this is going to be 2 to the exponent of 7. That is for x. H being raised to the exponent of our h is minus j. So we are going to have minus j in this case being raised to the exponent of a 0. That is the first term, where we know that any number to the power of 0, guys, that's a 1. All right, so anyways, we are going to move on to the next term. Remember, the next term I was saying, the part that has got x, you perform it as a derivative. This is the part that has got x. We are supposed to perform it as a derivative where you drop the exponent, you subtract 1. So we are going to do that throughout, guys. Okay, as long this part represents x, so we are going to drop the exponent, which is 7, 2 to the exponent of now. So the 2 remains as it is. So we subtract 1 on 7. So 7 minus 1 is going to give us a 6. Whilst h, this is our h here. Our h is increasing in terms of power. Remember, h will be increasing. X will be decreasing. H increasing. So h now, which is minus j, it will be minus j to the exponent of 1. Now is to the exponent of 1. From 0, we add 1. So that will be 1 over 1 factorial, the one on h. All right. Plus, we do the same thing. The part that has got x, always you perform it as a derivative. You drop the exponent, you subtract 1. So if we drop our exponent here, we are going to have 6 times 7. 6 times 7. You multiply these numbers. 6 times this 7, which is going to give us 42. Then on the part of x, which is our 2, we are going to subtract exponent on 6. So it's 6 minus 1, which is going to be a 5. The h, which is represented by j, is increasing from 0 to 1. Now it's at 2. So it's minus j to the exponent of 2. Everything over the power that is on h is the one that you use on your factorial. So this is over 2 factorial. How many terms are we having now? 1, 2, 3. Remember, up to 4 terms. So we need the last term plus. As long this represents x, drop the exponent, subtract 1. So we are going to drop our exponent, which is 5 times 42. So 5 times 42 is going to give us 210 times. So this part of x, we subtract 1. So it's 2 to the exponent of 5 minus 1, which is now a 4. The part of h, which is our j in this case, this is the part of h, increases. It's at 2 now, so it's going to be minus j to the exponent of 3. So it's increasing its powers, okay, over 3 factorial. Now we've got 4 terms. So this is how we're supposed to expand this. All right, so from there we can simplify. Remember, this was just writing so that we can expand properly, but this part of 2 plus minus j simply means 2 minus j. So we are just going to write as it was before. 2 minus j to the exponent of 7 is equal to, let us simplify further. Remember here, guys, any number to the power of 0, it's a 1. So here we are going to have a 1 times 2 to the exponent of 7, which from your calculator, you can simplify. All right, so let me just share back the screen again here. So that is 2 to the exponent of a 7. All right, which is 128. All right, so this is 2 to the exponent of 7, which is 128. So we are going to obtain 128. Remember, j to the exponent of 0 gave us a 1. All right, and I said j operates the same j that we know from our complex numbers. All right, so here we are going to simplify. Negative j to the exponent of 1, it does not affect. It's just like 2 to the exponent of a 1, which is 2. So negative j when raised to the exponent of 1 is going to remain as negative j. So meaning to say plus and a minus here is going to give us a minus. Then we can simplify the numbers now separately. So the numbers, we've got 7. So let's put a fraction, 7 times 2 to the exponent of 6. So this is 2 to the exponent of 6. All right, everything over 1 factorial. 1 factorial, guys, is just same as 1. So this will give us 448. But remember, we say there's a minus for j. So it's minus 448 times this j here. So it's going to be a j. All right, then on this part, we have got a j squared. If we check here, there is a j squared. So take note of this part because we talked about this from our complex numbers, j squared. That j squared is equal to minus 1. So here, let us see how we are going to simplify this part. We want to work with this part, minus j squared, this one. Okay, how are we going to simplify this? All right, so let us just have it aside here. Minus j squared like this. This is going to be, remember from your laws of exponents, if you are given 2x squared like this, 2 is raised to the exponent of 2. So it's same as 2 squared x squared, which is 2 squared, which is 4x squared. So it is the same thing with minus j. It's minus squared. And if you raise minus 1 squared, it's a positive 1 times j squared. So this is what is happening. Minus 1 squared, which is 1, then j squared. But we know that j squared gives us minus 1. So that means we are going to have 1 times minus 1. In place of j squared, we are now having minus 1. So 1 times minus 1, that's minus 1. So meaning to say, this whole part here of minus j squared, this whole part here, we simplified this minus j squared, we obtained minus 1. So we're going to substitute here with minus 1. All right, so this is what you're going to simplify from our calculator. We are going to simplify this as minus 1. We no longer have the j. We no longer have that j. We simplified the j and we got minus 1. So meaning to say we are going to have 42. So let us have our fraction. 42 times 2 to the exponent of 5. So this is 2 to the exponent of 5 in this case, times minus j squared gave us minus 1. So this is minus 1 like this, okay, over 2 factorial. So this is going to be 2 factorial like this, all right, which is going to give us negative 672. So we're going to obtain negative 672 like this. The j is no longer there. It's simplified. The j here was taken from the j squared, which gives us minus. So we no longer have a j. All right, that's the same thing that you're going to do here on the j to the exponent of 3. First, let us simplify the minus j to the exponent of 3. So just like the previous part, and a number, like a bracket raised to a certain exponent, it means we raise everything minus 1 to the exponent of 3. So a negative raised to the exponent of 3, it is going to remain as a negative 1. So that's negative 1 times j also raised to the exponent of 3. So let us get back to our complex numbers. How do you simplify j to the exponent of 3? Remember, we want to write this in terms of j squared. So j to the exponent of 3 is same as j times j squared. J times j squared gives us j to the exponent of 3. So meaning to say we are going to have j times j squared. Our j squared is minus 1. So this is going to be minus 1. So j times minus 1 gives us minus 1j, which is same as minus j. So it means simplifying j to the exponent of 3, we are going to obtain minus j in this case. So that is here we are going to obtain minus 1 times j to the exponent of 3. This is the one that we simplified here and we obtained minus j in simplest form. So this is going to give us minus j. So that means at the end, minus 1 times a minus j is going to give us a positive j. Minus times minus, that gives us a positive. So at the end, we are saying minus j to the exponent of 3, this part, is giving us minus j, is giving us a positive j in simplest form. We are getting a positive j. So guys, please make sure that you revise your your complex numbers, the use of the j, simplifying terms like j to the exponent of 19, j to the exponent of 23. This is what I'm saying. So once you understand this part, then this is the part that you are working with here. All right, so meaning to say here, we are going to have a j, this whole part here of minus j to the exponent of 3. This whole part here, we simplified it, we obtained a j. Just like this part, we got -1, but this one, we are getting a j. So that means we are going to simplify the numbers, only these numbers, then our answer is going to be multiplied to a j, all right? So let us see on our calculator. Let us have our calculator here, all right? So this is going to be, put a fraction. That's 210. So we're going to have 210. Okay, we need a fraction here. 210. Okay, what's happening with my fraction? Okay, 210 multiplied to 2 to the exponent of 4. 2 to the exponent of 4 like this. Then we do not have anything post. This is a j. So a j, you just know that there is a j. They leave it like that. Over 3 factorial. So this is 3 factorial like this, which is going to give us 560. So that's a positive 560 that we're obtaining, but multiplied to this j that we are given here. So it's going to be 560j. All right, so this is how we could have simplified this typical question. Guys, the issue of complex numbers, I always say each and every topic that you do, make sure that you know it properly, because it's not like that is the end of it. No, it's a continuation. The topic that you're doing now, it's a continuation to the next topic. That is the same concept that we had from this question. So this means that is to 4 terms. We have simplified plus and so on, but up to 4 terms. 1, 2, 3, 4 terms. All right. So let us check the other part of the question that we are given. In this case, we've got another question that I want us to check. All right, so let me check. I think it's on the next page here. All right, that's the question. We are given again, expand from August 2021. This is 2021 question 3, to expand x minus 3 to the exponent of 3 over 4 to 4 terms, 4 marks for that. All right, so they actually think that you actually know this formula by head. So they expect you to know this formula by head. That's why you see that the marks, they are so low. They actually want you to understand your formula by head, know it by head. That is the easiest way. Okay, so like I said, guys, okay, let us expand. So all we need here, we've got a minus. So just like the previous part, we are going to have this as x plus minus 3 over 2 like this, so that you can properly see the plus, the terms that we are working with in this case. So meaning to say, here we are having everything to the exponent of 3 over 4. So that is it. Once we can write this, this is your x. Here it's exactly in terms of x. Then this is the h part. So we are going to use the same thing, that x is starting with the exponent that you're given. That's x to the exponent of n. So you're going to have x to the exponent of 3 over 4, whilst h starts at 0. So that's minus 3 over 2, minus 3 over 2, starting to the power of 0. All right. So we move on to the next term, plus x. On the x part, you perform it as a derivative. Please, guys, if you can understand this way, that is the easiest way. You perform it as a derivative. You drop the exponent, you subtract 1. That's it. Drop the exponent, subtract 1, and that goes throughout and throughout. So we're going to have plus 3 over 4. Then x here, which is we are going to subtract 1 on this 3 over 4. So if we subtract 1, 3 over 4 minus 1 is going to give us minus 1 over 4. So it will be x to the exponent of minus 1 over 4. Whilst the part of h, this is your h part, is increasing. It is at 0 here. So it's going to be minus 3 over 2. It's now at 1. So 0, 1, 2, 3, and so on. All right. So everything over 1 factorial. Okay. Plus, we move on. We multiply again. We drop the exponent. Minus 1 over 4 multiplies 3 over 4. So from your calculator, if you multiply 1 over 4, that is 3 over 4 in this case, times minus 1 over 4, you're going to get minus 3 over 16 from your calculator. So that will be negative 3 over 16. Okay. The moment you drop this exponent to multiply here, you are subtracting 1 on the exponent. So that will be x to the exponent of negative 1 over 4, negative 1. So this will be negative 1, which is going to give us negative 5 over 4. So you're going to get negative 5 over 4. All right. The part of h, this is your h, is increasing. It's at 1 now. So it's going to be minus 3 over 2. Now it is increased to 2 over the factorial of that. So it's over 2 factorial. How many terms? 1, 2, 3. We need another term here. So that is the same thing. We are going to drop our exponent on x. So x always is dropping the exponent. As long as you're dealing with x, you drop the exponent, then you subtract 1. So we are going to drop this. So now it's negative 16, negative 3 over 16 times. We drop this exponent to multiply here. So it is going to be negative 5 over 4. So this will be negative, we are going to obtain something like 15 over positive 15, okay, positive 15 over 64, positive 15 over 64. So that will be 15 over 64, while least we are subtracting 1 on the exponent. So this will be x to the exponent negative 5 over 4. Negative 1 is going to give us negative 9 over 4. While least h, the part of h here will be increasing. It's at 2. So now it is going to be at 3. So that's at 3, everything over the 3 factorial. So that goes on and so on and so on and so on up to, I don't know how many terms, but here we need up to 4 terms. All right, so that's it. It's you and your calculator now. Now it's you and your calculator. So remember this, the plus or minus, you can get it back to the minus that it was before. So it is going to be x minus 3 over 2, everything to the exponent of 3 over 4, which is equal to, let us simplify now, this one to the exponent of 0, that's a 1. So that means we are going to remain with x to the exponent of 3 over 4. All right, let us move on to the next term. Here we need to take a lot of caution here. So let us see what's going to happen. We have got this part and this part over 1 factorial. All right, so let's use our calculator. Just like the previous part, we need our calculator here. So let me just be patient enough. Go back to the calculator so that we can understand all of us here. So you're going to have it as a fraction, 3 over 4. So that is 3 over 4 like this, times negative 3 over 2. So you're going to put a bracket here, negative 3 over 2 like this to the exponent of 1. So that's to the exponent, which does not affect actually. All right, so over 1 factorial. 1 factorial also does not affect, but just for the revision part. So you're going to obtain negative 9 over 8, but with x to the exponent of minus 1 over 4. Take note, there's x here to the exponent of negative 1 over 4. All right, so that's negative 9 over 8x to the exponent of negative 1 over 4. Then you can simplify the same thing here. We are going to simplify the same way. This time we've got negative 3 over 16, negative 3 over 16. That is times this part, negative 3 over 2 squared. So just open a bracket, negative 3 over 2 squared. So gonna open bracket like this, you square it over 2 factorial. All right. So I need this part here over 2 factorial like this, over 2 factorial. So this is going to give us a negative 27 over 128. But remember, there's x to the exponent of negative 5 over 4. So that will be negative 27 over 128, x to the exponent of negative 5 over 4. We simplify again this part here. We simplify this part. We multiply again. So if you are used to this, you can do this much faster. All right. So that is 15 over 64. 15 over 64 times, in this case, negative 3 over 2. So this will be negative 3 over 2 to the exponent of 3. In this case, that's to the exponent of 3 over 3 factorial. So this is over 3 factorial like this. All right, so that is negative 135 over 1024. All right, so we're going to take this as it is, negative 135 over 1024. But there is x to the exponent of negative 9 over 4 like this. Okay, so this goes as on and so on and so on. All right, so this is what we could have written our answer as. But this is a risky, very, very risky to leave our answer at this stage because you do not know how your memo is going to be presented at that stage. So it is best for you to simplify further, writing your answers in simplest form. But this is what you could have just written our answer as. But you do not know, guys, what's going to happen. Which answer are they presenting on your final in the memo there? Just take, normally for the binomial expansion, they'll just give an answer. In the memo, they just give you an answer. They don't even show the steps. These steps that I'm showing here, you don't even see them in any memo that you're going to have. They just give you an answer. So if you leave your answer this, maybe they simplified further. So it is best for you to leave your answer in the simplest form. So the simplest form is getting rid of the exponents, the negative exponents, this and that. All right, so this is going to be x minus 3 over 2. So we've got x minus 3 over 2 to the exponent of 3 over 4 equal to, all right, so let us take from our laws of exponents. Remember, we have got x being raised to a certain exponent, x raised to the exponent of a over b, which gives us the bth root of x to the exponent of a. So meaning to say the denominator is the one in the root sign. So this is going to be the 4th root of x to the exponent of 3. All right, minus 9 over 8. We have the same thing. If we drop this, we remove the negative, it is going to be x to the exponent of 1 over 4, which is going to be the 4th root of x to the exponent of 1, which is just 4th root of x. All right, the same thing here. We are going to have it as minus 27 over 128. We drop this one down so that it becomes a positive. But the moment it becomes a positive, it means 4 is in the denominator. So it is going to be the 4th root of x. So this is going to be the 4th root of x to the exponent. All right, so let me rewrite this so that we can see properly here. So this is going to be the 4th root of x. So here there's a 4 here, the 4th root of x to the exponent of a 5. All right, so that's to the exponent of 5 minus also this part. We drop the negative here to remove the negative. We write it down. So it is going to be 135 over 1024. The moment we have it as x to the exponent of 9 over 4, we are applying this same law. So it's the 4th root. So we're going to have the 4th root in this case of x to the exponent of 9. All right. So normally on your formula sheet, they will just write the answer like this. They don't even show the steps. Where is it coming from? They don't even show. So that's why I'm saying, please, if you are answering your questions, step by step, show the indication of where you're coming from, where you're going, the final answer, so that you obtain the full marks. You never know where is the full mark, where is the marks given on the memo that is being given for that certain or for that particular year. So try by all means to simplify as much as you can. So that is the advantage of also watching these videos, so that you understand what exactly is required when you're answering your questions. Understanding a topic is fine, but how are you going to answer your questions? How are you expected to answer your questions? That is the most important thing also to consider for your exams. Okay, anyways, guys, that's what we had from Meson African Motives, working on mathematics N4 revisions as we are preparing ourselves for the exams which are ahead of time. Don't forget to join the membership platform. By joining the membership platform, it's actually gives us a lot of a lot of videos that can actually help us a lot to save others. If you can do so, make sure that you join the membership so that it can help. Anyways, that's it, guys. Let us meet in another platform. But for now, that's it till we meet again.